RemoteLaunch is basically designed as a tool to, as its name says, to launch tests on other machines, typically other machines, but it could be the same machine. But usually, it's to launch tests on other machines written in a variety of technologies and have all the results come back to Spira. That was the original design. And sort of go back in history, originally what happened is when we first released Spira Test back in 2008-9, we had, before we even had REPs, clients had things like UFT, Load Runner, Test Complete, Squish. Those were kind of the tools that we were seeing at that point. And obviously Selenium was just coming out. But they wanted to run those tools and they wanted to have all the results come back to Spira. And each of those tools was different. They were running on different machines and they wanted everything to come back into a central repository, which is what ALM used to do or does, except it only does it with its own tools. So we came up with the idea of let's build an application called RemoteLaunch that can sit on a, and it's, because it's running GUI tests, it's going to sit on a desktop and it can have different plugins. So that way we don't have to write a separate application for every single tool we're going to integrate with. Because originally we'd written a launching tool just for UFT and we suddenly realized that wasn't scalable. So we decided let's create a launching tool and then let's write plugins for it, which we can write, which would basically match each of the technologies. And it gave us lots of flexibility because some of those tools we're going to launch have command lines. Some of them have basically ActiveX APIs, some of .NET APIs, some of other things. And so it gave us a lot of flexibility into being able to interact with the other tool and then be able to launch it and get results back. We also recognized that there was going to be a bunch of people who had built something themselves that we were never going to support ourselves. So we created a fallback called the command line option, which is a generic plugin, which will let you run any kind of command line tool, parse the results and send it back. And it's more simple than the others. It doesn't have as much, I guess the reporting won't be as rich, but it can be used to any tool. It doesn't require one of the plugins that we've built. So that's the concept. Before I go into the specifics, does that all make sense?
That makes sense.
Okay, good. So, and then we came up with, I think, a fateful decision, which was to name things certain things. So we decided we were going to come up with two concepts: an engine and a host. So let's start with the easier one, I think, is automation hosts. So in any given Spira product, you will have automation hosts. So my machine is called TARDIS. That's the name of my Windows machine. So I would create a host called TARDIS. If you had a machine called VM ABC, VM 123, they would be the name of the hosts. And the name is just the display name. The token is actually more important. That's like the identifier of it. And in actual fact, in retrospect, we probably should just have one name. But anyway, we do have these two. And the more important one is the token. And so I often make them the same when I'm creating an actual data entry to make it simpler. So my machine is called TARDIS, and it has a name called TARDIS and a token called TARDIS. That's my machine. It is not related in any way whatsoever to the technology I'm running on that machine. And that's really important because this is the automation host, and it has a token. Now, we also have an automation engine, which also has a token. This is where we get into the confusion and probably what was retrospectively not a good naming convention. If you go into the system administration menu, we have what's called automation engines. They're listed in this section, but you can add additional ones if they're not with the sample data load. They're right here. The idea is that every customer would go in here and they would have whatever plugins they're going to use in their organization. They would enable them or add them if they're not already listed. And the key is that they have a display name, a description, but they also have a token. Now, the display name, you can call it whatever you like. Description, you can call it whatever you like. The command line has to be whatever's in the documentation, and it typically is the DLL's name. If there are multiple versions, it could be slightly different. Like it could be jmeter2.dll versus jmeter or something. I mean, this is possible, but the documentation in Spiradocs will tell you whatever one you're using, what the name is. So for example, if it was UFT, if you go in here and it describes it, it's going to tell you what the name of the DLL is and what the engine is that goes with it, like that. So just to recap, we have automation hosts that are machines that we run things on, and automation engines, which are like plugins. They are different technologies. They are things that can know how to connect to a different type of testing tool, whether it's a commercial tool, open source tool, or just the general command line.
Question.
So, okay, question, yes.
Is the automation, is the host the machine where the tests are run?
Yes.
Okay.
So on my machine, I have RemoteLaunch installed. And if you go to my client setup, I tell my machine that this is how you get to Spira. This is the login and password API key. And this is my token. This is who I am. I'm TARDIS. I could be VM123, but I'm not putting in here UFT or test complete or Selenium or anything like that, or Tosca. That's very important. This is the machine, not the technology. Then what I did is, if you go into my installation location, if I can, it's in C:, program files, Inflectra, remote launch, extensions. There are 4 in here, 1, 2, 3, 4. And so because there are 4 in here, if I go back to remote launch, there's these different tabs. So these are the different tabs we've loaded. 1, 2, 3, 4. And if you're not sure which ones are loaded, you can go to the menu for the remote launch and go right-click, help, about, and it will tell you here what's loaded: command line, JMeter, Tosca, and UFT. So these are the engines that my instance of remote launch has. Now we're going to talk about licenses. Every organization will have a license that they bought a remote launch, and that license is an engine license, meaning this instance of remote launch can load up to X number of plugins on this machine. And I've got a 10 engine license, so I can do loads. If I have a 2 engine license, I've got more than 2 plugins loaded. I would need to remove 2 of the DLLs and have only 2. The same license can be used on multiple machines, but it is tied to a specific number of technologies. And then we did it that way, and I think it's still a good way, is that we didn't want to restrict people on how many machines they were running, because they're already paying, especially with the commercial tools, they already were paying test complete, a license fee for every single test execute. The reason we did it by the engine was we've typically found that the hard part with remote launch is getting it up and running and configuring it. And once they log tickets with us, the number of tickets will vary by the number of different plugins they're using. And once we've figured out one plugin, they've usually figured it out for everyone else. And then it's the next plugin that causes problems. So that's why we based the license on the number of plugins. It was to sort of compensate for the amount of tech support they were likely to use. So that means you have to load the plugin, the extensions in here. And so my particular remote launch can launch command line, JMeter, Tosca, and UFT. So if I was to go into Spira, and if I go to a specific test case, if I'm going to assign any test sets to Spira, to TARDIS, sorry, I need to make sure that it's only using one of those 4 plugins. Because any of the other ones, it will return back an error saying, cannot launch test XYZ because that plugin doesn't exist. So if I try to run a Ranorex script or test complete script, it's going to fail because my remote launch on this machine does not have that plugin loaded. And Spira doesn't know that, and it won't stop you. So it's not able to communicate to do that. So if I go into regression tests, if I went in here, I'll just grab one and I'm not going to actually run it. But if you go in here and you go to the plugin, you could say, I'm going to use, say, UFT Quick Test Pro, and I put the path into its location where it was, see my test, 1, 2, 3, my test, something like that. When you hit save, and mark it as linked, that's going to basically tell it on the machine that runs UFT, that's where the test can be found. And in the documentation, the file name is specific to the technology, because sometimes it's a folder, sometimes it's a file name, depends on the technology we're actually using, they're all different. But you hit save, and now you can put this test case into a test set, and that test set can then be assigned to my machine. Now, a test set can have multiple different types of test case in it. As long as remote launch has the plugin available, it does not require a different test set. So I could create a new test set called, multi-tool testing. If you go into it, and if I add test cases to it, I could have a UFT test case, a Selenium test case, a Tosca test case, and a JMeter test case. Anything that's basically listed here in these 4, I can add any of these 4 kinds of test case to a test set that will be assigned to TARDIS. So I go in here, I go my regression test, and I would grab the ones that are appropriate. I mean, these are not necessarily all those types, but imagine they were. I've got 4 test cases, one of each technology, and now I assign it to TARDIS, hit the save button, hit the schedule, and now my machine will go ahead, and it will basically, remote launch will open up. It will basically get the test case from Spira, gets the test set, opens the first test case of the test set, which would be book management, looks at book management and says, okay, it's a Tosca script. Let me load the Tosca DLL. And the Tosca DLL knows how to interpret the file name. It will do whatever Tosca does, and then gets results back. Then it moves on to the author management. Author management might be, oh, this is UFT. Let's launch UFT. UFT runs the thing, get the results. Now let's go to sample fixture 1, 2, 3. That's Selenium. Let's launch, and so on. So that's how it basically works. So before I go any further, how does that sound? That makes sense.
It makes sense to me. It's helpful in both ways. I don't think I have any questions right now.
So it was trying to run 2 plugins on 1 machine, right?
They were trying to name the automation host, I think, and the automation engine the same thing.
Yes.
That.
That's always a sign that someone's confused. They should never be the same. And I would deliberately not make them the same. Even if that machine only has UFT on it, don't call the machine UFT. Call it BMA. Anything but UFT, because it's just too confusing.
Yeah, makes sense. Okay.
And also the fact that they only have 1 license
is an issue. They will need a second one. That if they're going to launch 2 machines, 2 plugins on 1 machine. 2 technologies on 1 machine. They will need a 2 plugin license. Otherwise, they don't have to. They could use 2 machines. They could have 1 machine running Selenium, whatever it was, and 1 machine running Test Complete. That's also fine. The license is per machine. We're relatively generous. So if you only have 1 license, you can run Test Complete here, Selenium there. You just can't run them both on here. What else would be helpful?
How do you tell Spira, I want to execute the following test, or test cases, or test sets?
In terms of an order for remote launch. Okay, yeah. So let me go back. I only have 1 physical monitor, so it's easy for me to stop sharing when I want to talk to people. Anyway, so the way that works is there's 2 ways. You can first of all, what you normally do. Let's say I want to run these 4 tests on this machine at some point in time. So what you'll do is you do what I just did. Mark it as TARDIS. I put the release in. I then put the date and time, and then I hit the recurrence. And if I hit save now, this is probably going to fail because these tests have scripts associated with them for real. All I have to do is hit save. And remote launch, which is sitting in the background, it's going to be polling Spira, and it won't find anything right now. But if I do save a test, it's going to find that test, and it's going to basically say, oh, this test that's been scheduled on this machine with this date and time. So Spira stores the schedule information. Remote launch is polling it to find out when and what to do. So it really is as easy as that. You just simply set the machine, set the date and time, and hit save. Now, there is a second version of this, or option, where if they are using something like a pipeline from a GitLab, GitHub, Jenkins, they can trigger it from there. So to do that, slightly different, but not massively different. You do everything the same, but you leave the plan date blank, like that. That's why I'll hit save. And what you do is you check this box saying schedule on build as yes. Hit save. And when you do that, it's very important you set the release. Because what's going to happen is if I go over to release 1, anytime Jenkins or any of the build tools that we integrate with, because it could be GitLab, GitHub, CircleCI, ... They report back their builds. Well, those builds are tied to a release. So if one of these builds drops against a release and the build has succeeded, the system is smart enough to auto-schedule the date and time. It basically says, oh, build passed, release 1. Let's get me all the automated sets, release 1. Oh, here's one of them. Let's set its planned date to right now. And that will force it to run. And that's why you got this post-build delay. If you add like a 2, 3 second or 10 second or 100 second delay, if you want to have things so that the build is finished, deployment is done.
So these are then tests that are triggered by the pipeline.
Right, the pipeline is effectively, when the pipeline reports back to Spira that it'll pass with any code commits, what it's doing is, it's in addition to that, it's telling Spira to update schedule on a certain number of test sets. The build is not directly calling the remote launch. The build is basically updating data in Spira so that the next time remote launch polls, it knows there's something to do. Question?
Yeah. So Adam, if the build fails, then test will not run. Is
correct? That's the benefit. Because the reason why we did that is otherwise you could schedule. Let's say you said you'll build at 9 o'clock. You could in theory schedule a test at 9:30. But if the build fails, there's no point doing it because the code is not in a good state. So that was the design idea. So to that way, it's only going to happen when the build passes, when the test is ready for testing.
That makes sense.
Cool.